Happy Tuesday. I hope you had a great Memorial Day weekend. So as we finish up the course this last week of new instruction, we'll be talking about the quadratic formula. So you might recall we spent some time last week working with quadratic equations that do factor. Like for instance, x squared plus 4x minus 60 equals 0 is wonderful because it's an exponent degree 2, degree 1, degree nothing, equal 0. So we're going to try what we call the AM method, you might remember. So we're going to try to find two numbers that multiply together, give us 60, but adds up to 4. Now keep in mind though, when we multiply to get 60, it has to be a negative 60. So if you remember, your signs will be one of each. Now be careful. What two numbers that multiply together give us 60? Add up to positive 4. You got it. Negative 6 and positive 10. So if you recall, once we factored, we set each of those binomials equal to 0, and then we would solve. Now obviously if we had a graphing calculator, this would be made a lot simpler, just making do with what we have in the situation here. But I know you guys were all taught this in Common Core Algebra Year 1. So these are your two answers. They're also known as roots. Perhaps you might remember hearing the word roots or x-intercepts. But what we're going to face this week is a situation where we're going to be forced to use what's called the quadratic formula. Now, those of you who remember the reference sheet on the Common Core Algebra exam, this formula is always given no matter what year, what course, what Regents exam you're taking. This works 100% of the time. So the way this quadratic formula works is still gives you the x values, but it uses the coefficient, the b's, the a's, and the c's from the a that's usually in front of the x squared, the b, which is usually in front of the x term, and the c. So that's why we were talking about the importance of making sure your quadratic equation is not only set equal to 0, but it's in exponent order, degree 2, degree 1 to nothing. So we're going to look at 3 examples today, and then I'll give you some practice problems this week from the quizzes because it's easy for me to check your understanding, and that we can do as many times as you like. But whenever you use the quadratic formula, make sure you write it down. There's a really neat little song that goes to it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Used to watch kids try to sing it and hum it as they take a quiz or test, but no more. The state allows us to give it to you, so you don't need to memorize like when I was in school. Or when I first started teaching back in 1990. When did I first start teaching? 94. My gosh, it's been that long. Anyways, I digress. So here's a quadratic equation. It's in standard form. Set equal to 0. Degree 2, 1, wonderful. So the first thing I always recommend students is write down what the a, the b, and the c values are. A is the number in front of the x squared, the 3. The b is the invisible 1, so write down a 1. And the c value is negative 7. So I make my substitution. X equals. The formula takes the opposite value of b. So since b was 1, we plug in negative 1. Plus or minus. Big square root. I try to make it extra long because I tend to write big. b is 1, so 1 squared. Minus, it's always a 4. I always use parentheses to show multiplication, and I'll tell you why in just a moment. So 4 times 3 times the negative 7, and it's all over 2 times a. So if a is 3, 2 times 3 is 6. So the denominator is 6. So we have negative 1 plus or minus. Now, when you use Texas Instrument calculators, which seems to be the big push, and I know you don't have your own calculator, but just as a reminder, when you type this in with the PEMDAS, 1 squared minus 4 times. You could get away with times 3, but you're not going to get away times negative 7. You need parentheses around those negative numbers. So that's how I got the 85. And just go ahead and leave your answer like this. This is an irrational number, by the way. It doesn't simplify any further. And it makes sense to me because the original quadratic equation does not factor. We can't break it down. Questions? Maybe now's a good time to pause, write down, and then let's take a look at the next example, number 2. Now, number 2, x squared minus 6x minus 13 equals 0. This is an interesting one because a is 1, the b value is negative 6, and so is the c, negative 13. But when I plug this in, the negative, how do you negate a negative 6? It's sort of like turn the lights off, turn the lights on, off, on, back. It's like true, false kind of a question. So it becomes positive 6, but you don't need to put a positive sign there. It's understood to be positive 6. So see, the B does take on the opposite sign, plus or minus. Now here again, the importance of the parentheses. If you forget the parentheses, the calculator will give you the wrong answer. Negative 6 squared minus 4 times 1 times a negative 13 all over 2. So when we finish this one up, again, I want to just show you the importance of this calculator and the parentheses. Negative 6 squared minus 4 times the 1 times, oh, I need a negative 13 in there, right? So I need parentheses. I get here 88. And then I'm done. Now, last example, one more, call it good. Our A value is 1, our B value is negative 2, and our C value is negative 6. Once again, I see negative signs, so I need parentheses around them when I plug them into the quadratic formula. X equals 2, that's the opposite of negative 2, plus or minus negative 2 squared minus 4 times 1, look at that negative 6 with parentheses, over 2 times 1. Usually this part here and that part there are the two easiest. Write the plus or minus. The hardest part is this PEMDAS, and I hate to say it, but where people mess up, they forget the parentheses. So again, this week we're going to focus on the quadratic formula, do some review work of that as we finish off the course. Our last day officially of instruction is June 12th, so it gives us plenty of time to get caught up and get squared away. If you have any questions, shoot me an email. Thanks. Have a great day.